So everybody here made a great introduction to the whole ecosystem, and today I'm hoping to talk to you about a new component of that ecosystem, I think, but first I want to thank all the organizers for this opportunity. I think OpenScope is, I believe, one of the first astronomical observatory in neuroscience, and I'm going to try to explain to you that sentence. But first, we rest on the shoulders of giants, and so this is a community project. I want to start with the community first. All of what I'm presenting today is done thanks to a collaborative effort across the Institute. There are scientists, technicians, managers, engineers, animal care, all of these people that made that pipeline possible. And in addition, the OpenScope project is steered by a committee of peers. Some of these are here today that really are an influence on the direction. And so nothing will be possible without them. I'm especially thankful for them. And eventually, we also now funded by our community. So I'm thankful for the Brain Initiative for supporting this work. So I said we rest on the shoulders of giants. More than 10 years ago, Christophe and Clay published this paper, and you have to sort of think, at that time, there was no animals in the pipeline. So that was a vision that was in the making, but a daring vision. And we actually, I think we are delivering on this promise, and I've built multiple of these pipelines in our community, and in some ways inspired other laboratories to do the same. The first on the left is highlighted in this paper, that is the two-photon pipeline that many of you have actually used to generate new insights. And the second one on the right, sort of using the foundations of the two-photon pipeline, we deployed the same ideas for neuropixel recordings. And over the years, we matured this pipeline to have a portfolio of capabilities. So this is a collection of two-photon and neuropixel recording, but also having the ability to have behaving mice, reconstruct the brain in 3D, and have a web product in the end to deliver the data set to our community. And so these effort translated into, I think, impact in science. So on the left, you see the number of publications that have been released from a publication using data from an observatory in astronomy. It was released a couple years ago as an analysis of the impact of the Keck telescope in Hawaii. And on the right, this is a very recent publication put together by Saskia, Josh, and Christophe on the impact of our dataset. And so as you can see, we have now more than 100 papers that are using those datasets. So there's clearly a need in our community for this ecosystem of dataset. And so when we saw it coming, but we also realized that there are also a need for accessing these tools, not only for the data, but also for the platform themselves. And in some ways, you can think of neuroscience as limited by its tools. Many of our research is done by laboratories that, for instance, have the ability to record one brain area at a time. But if you now build a platform that can record brain-wide and make this available to everyone, you essentially break the ivory towers and allow more questions to be asked. And so we think there's a future in our community for this component in our ecosystem that allow to integrate the lab together. And so we decided to try it out in 2017. Again, at the time, when we started this, I got a lot of questions, like, why are you doing this? But our idea was to maximize the impact of a platform, but also to build a community and develop the neuroscience ecosystem. So we went through two phases with this OpenScope program. The idea is sort of allow scientists across the community to sort of submit projects, the same way as the Hubble telescope functions. So 3 years we run with internal funds, and in 2021 we were thankful for the NIH support, and have been running under this funding since. This resource has a number of components, and it's important to me that we leverage all of the ecosystem that you in the room also are building so that we create a hub. And so the first component that is new to this, is a new component of our ecosystem, is the access to the pipeline. So people can submit projects on a yearly basis. Our process is double-blinded, so we want to avoid as much as we can any bias and really focus on the science. In addition, and as highlighted by David, it's really important to leverage the modern technologies and help develop cloud data ecosystem that exists. And so to do that, we started by collaborating very closely with the NWB and the Dandy team, indeed, not to reinvent anything and just help everything flourish together. And the last component of this platform is what I consider a technical hub. So on a yearly basis, we allow scientists to come at the Allen and learn how we acquire the data and also create a place of exchange. So we organize workshops. I'm going to highlight one of these in some of the slides. Our process is double-blinded. So we are right now in the middle of selecting the next year project. So this is done over the summer. So we have first a letter of intent that's submitted typically in September, just last month. So we actually this last week we sent feedback to the applicants and request full proposal. The intent is to to help teams draft their proposal and also avoid people spending too much work if it doesn't fit our capabilities. And then the projects are written, the full proposal. It's a 6-page document. It's not. I don't think it's too expensive work. And then it's reviewed by peers, so by the community, so and eventually by the steering committee. I'm not part of the selection decision. So we run projects for the community by the community. We've run so far 9 projects, and I can't go over the science of all of them if I will go beyond my 15 minutes. But I'm highlighting here 2 examples. One of which was actually led by Colleen, which is in the room, and is a strong believer in open science and has done everything she can to make it available. So you see on the left an example of the analysis that they conducted in collaboration with Joel Zilberberg and Blake Richards. They were interested in looking at dendritic and somatic response in the context of unexpected stimuli. I encourage you to look at the paper. It's now accepted officially in the journal, but it's on bioRxiv. And on the right, this is a recent paper on neuropixel done by Yi-Young Shin and Ilal Adesnik, where they look at the neural correlate of illusions. So this is just highlighting the different things that things we can do, but the academic impact of the platform is growing over the years as we push data out. Not only do we create academic papers, but we also release data set on Dandy, thanks to our collaboration with NWB and the Dandy teams. And in some cases, actually have publication just highlighting how to use the data. You feel free to go over those papers, but just envision that this is going to grow over the years. Our long-term vision is to actually go towards brain-wide recordings. The platform has been maturing over the years. We have pushed new technologies. On the left, you see examples recording done in neuropixels. We've sort of evolved the implant that we use in mice to give full dorsal access, so that, and it's done at scale. And on the right, this is our own current ongoing work to have a curved piece of glass for 2 photons to access the whole dorsal surface. This preparation was made available this year to Project Propose. So I mentioned that we also a community hub, and this can be in many ways. But an example of this is a yearly workshop that we co-organize with the NeuroPixel team and Nick Steinmetz in Seattle. Again, resting on the community and not trying to reinvent anything if there's a way to make synergies. And so this has been, I think, very successful. It's a 3-day workshop. Some of you have sent students, I think, as I recollect. And we'll have this again in June. It's a great place to learn about everything from the beginning of surgery to the very end, including data analysis. And so it's a place of exchange. But not only for the people that apply to OpenScope, but also people that do their own analysis in their lab. So what have we learned? Over the years, that's actually really true in my opinion. We learned that the model resonates with our community. I think there's a desire to build a hub that allow our community to interact together and integrate dataset and experiments. Internal and external collaborations such as these can work, and they create scientific values. In some cases, data collection can be fast, especially when we leverage the Allen Institute pipeline. But, and I think that's true, data analysis can still be slow. And because that takes a lot of time and insight to derive insight from dataset. And that's just because of pre-processing, validating the data, the metadata that David mentioned. And so we think that there's an opportunity to continue building on this foundation, a data analysis ecosystem. So this is it will be the end of my talk. So we've doing two things on this. The first thing I'm really excited about is what we call the OpenScope data book. It was mentioned by Satra. So here we are leveraging, again, what exists. So all of the package, I just talked with Alex about TCA, where we just pushed, or Zebra that Mackenzie developed. So we're putting out a set of notebook that show you how to go from the NWB files to some of the analysis that are done by everyone, LFP analysis, the dimensional reductions. It's actually striking that today there's no one place to learn these things, and that students are on their own to learn it. And so we're building this, and our hope is that it will accelerate the OpenScope projects, but also people that are not part of OpenScope project, and build a community around it. The second thing is we're working very closely with David and all the other teams in infrastructure to leverage code oceans in bigger depth. And so we envision that the OpenScope program will eventually give access to those capsules so that the teams that are accessing data can also build their own pre-processing modules so that we don't have to do it, and they can sort of debug it on their own and continue building an ecosystem on top of this. In some cases, we'll continue to push, and we will continue to push data to Dandy, but these are just complementary to one another in many ways. So I'm super excited by this direction. And I'm conclude. Maybe we gain some time back from the previous talks. The first thing is the link is up there. It's new, so anyone here in this room can apply. Please grab it. Our next call is we closed the LOI this year, but next summer I'm going to continue, and we'll continue. I hope I convinced you that this is the first astronomical observatory. I hope that more will come. On this front, I think there's a dear needs in our community for integration, and I think it's also about experiments. We've completed 9 projects. There's 3 more ongoing. We'll continue to push paper out. I envision a future where a community observatory is serving our community in the world, and we are laying these foundations. Thank you.
Any questions? We're actually, thanks to the Allen Institute team, we are back on schedule. Right here?
Did you observe already the effects of your inoculation of people with good data and technologies that they start to use in the OB files and kind of spread the culture of using them because they've got hands on them, right?
Well, that's a really interesting question. There's still 45% of our community is using MATLAB. There's actually some that are still using Igor. And a big proportion of the OpenScope team are using this older language. So we need to move on from this older language. But what we're trying to do with the data book is to help facilitate the onboarding of Python. But yeah, I'm still like N-10, like thinking about Igor at the moment. Yeah, it's. I mean, you can. The budget, like things are public. It's about $1 million a year And so we run 3 or 4 projects, so you can do the math. It's a really generous project. Like it's like getting a grant when you get selected. It's a lot of volume.